with that, we'll give it to Luke Marsden of Helix.
Awesome. Thank you, Tamo. Cool. So, hi, everyone. It's really amazing to be here, and actually really special for me because at the start of the pandemic, I was one of the founders of the MLOps community in Bristol, in England, and it's kind of amazing to be here in San Francisco and to see that the community has grown so much. So, oh, thank you. Yeah, I want to talk a bit about some of the lessons we learned from building Helix. So I'll first show you what it is, and then I'll talk about what we learned by building it, and hopefully that can be helpful to other people who are building generative AI stacks on top of local LLMs. So what we built with Helix was kind of the bottom layer is a GPU scheduler. So we started out late last year seeing the fact that Mistral 7B came out, and like this was amazing because all of a sudden you could run an OpenAI like a sort of ChatGPT quality model locally on your own infrastructure, on your own like GPU. And then the other thing that happened was that you could fine tune those models on local infrastructure. And so I said to my co-founder Kai, like, oh, it's time to have another go and build like an AI, like a Gen AI stack based on these new open source models. And so kind of out of necessity, we built a GPU scheduler because we didn't have many GPUs, and we wanted to be able to run like fine tuning on the same set of GPUs that we could run inference and keep those models running for a long time to kind of trade off like latency with GPU utilization. So we built this GPU scheduler, we built this stack that allows you to do inference and fine-tuning, and then we went out into the market in December last year with these two hypotheses. And the first hypothesis was people will care about running models locally, and the second hypothesis was that people would care about fine-tuning. And we heard very strongly from the market that people really do care about running LLMs locally. So, for example, we had our first customer in Germany come show up in our Discord within days of the launch. But we also heard from the market that people were kind of meh about fine-tuning. And I think that's because a lot of people wanted to do RAG instead. I believe fine-tuning will come back, and we can talk about that later. But so we added RAG to the stack. We also added this ability to call APIs on behalf of the user. And we built on top of the shoulders of giants by layering on top of Olama, Cog from Replicate, and the Axolotl project. And then more recently, we've added this ability to do, if you know the GPTs feature in ChatGPT from Olama, from OpenAI, we also added the ability to build GPTs on top of local models. And additional to that, when you build GPTs on ChatGPT, you're just pointing and clicking in a web interface. And that's fine for prototyping stuff, but as DevOps people, we know that that's not okay for production deployments of things. That you really need to have like a version-controlled YAML spec, just like we always have done with like Kubernetes and Bacalhau. And so we have a YAML spec as well that we call the AI spec that we're proposing. So yeah, Helix does like a bunch of things. I don't really have much time, so I won't go into all the detail, but you can basically see on the left-hand side, we have these kind of data pipeline pieces where you can take data, do text extraction, vectorize, put into a vector database. Also, we have this whole fine-tuning stack, which, like I said, we put out in December to generate training data for models from documents. And so you chunk up those documents and then have the LLM generate, like you literally prompt the LLM to generate a quiz around the documents, because that will be the same kind of queries that you get from users. And then you can train a model on that. And then we have this kind of distinction between the interface layer, which is how users interact with the applications, and what we call the app layer, which sits underneath it, which has these different pieces like RAG, fine-tuning, API tools. And we also plugged in GPT-script. I'm really glad the GPT-script team could join us tonight, and thank you for that amazing presentation on how you got the open models working with function calling. So with Helix, we're trying to be the best place to run GPT script in production on the server. So without further ado, I will try and do some quick demos. So the first thing I want to do is just show you Helix apply-f. So here I have a paranoid Android app. So this is the Helix YAML spec. And so what you can see is I've got an application where I want to pretend to be Marvin, the paranoid android from The Hitchhiker's Guide to the Galaxy, which is obviously very useful. So I can just run Helix apply-f to Marvin, and then I can go and talk to Marvin. Let's go here and go to the App Store, and then we'll chat to Marvin in San Francisco. What should I say to Marvin? Are you happy? No, I'm not happy. Why would I be? Nothing matters anyway. So shall we make Marvin a bit happier?
You still eat words.
Okay. Well, let's just update Marvin. So now we can just do Helix apply-f. Of course, what I should have done is committed the YAML file to a Git repository and then done GitOps. And you can also do that with Helix. You can connect to Git repository, so you're kind of constantly versioning things and doing it properly. But just for this quick demo, I'll show you happy Marvin. So let's see. Come on, Marvin. How are you feeling today? Yay, it worked. Okay. I should probably make it a bit bigger. Oh, yeah, cool. So that's great. So the next thing I wanted to show you was that I believe it's important for DevOps people to be able to deploy these applications, but I also think it's important, as I'm sure OpenAI did when they built GPTs, for people to be able to build these apps themselves if they are business people and not engineers. And so here's an example of the app editor that we have in the product. So here you can, here's an example of like a Starbucks IT product catalog. So suppose that your Starbucks' IT department, and you want to provide a helpful assistant. So what you can do here is you can set up different knowledge sources. So suppose that you want to be able to tell when different Starbucks stores are open, so you could daily scrape the URL of the Starbucks website, and then you could ask questions like, when is the Austin campus Starbucks open? And hopefully, yes, it will tell you, and it will also give you a reference because it's RAG. And then you can also integrate with APIs. So here, for example, because we're the IT department, we're responsible for the laptops in the business. So what laptops are available? And then that will go and make an API call. So it will construct, it will classify the user's request. It will construct the API body. It'll post or send the API request to the server. And then it will summarize the response in a non-technical way. And you can see that that's working there. And then we also have support in here for GPT script. So you can go in and paste GPT scripts in here, and that all works. So that's what we built. And I want to talk a bit about like kind of the lessons learned from that. So I already talked about the kind of the hypotheses that we had when we launched the product. This was around running models locally. Everyone said, yes, that's a good idea. We want that, especially like highly regulated enterprises. Lots of telcos can't use the cloud, which is interesting, and so they want to run models locally, and they need the ability to do that. We also, like I said, we learned that the demand for fine-tuning wasn't really there from the market, and that was quite interesting. But I think fine-tuning will make a comeback because as people start putting these models into production for high throughput use cases, running them on large general purpose models is going to be very expensive and use a lot of power. And I think it will be better if we can take general purpose models that are doing a job and use those models plus the apps to generate synthetic training data for small fine-tuned models that are very good at doing that same job, and then like distill the capabilities of the general purpose model into a specialized model for that specific job. Like maybe the special purpose model gets good at knowing exactly how to call specific APIs, or do specific things with a database schema or something like that. And then, so that's kind of the hypotheses. In terms of the fine-tuning, we did a bunch of work on making the fine-tuning work well, even though it ended up not being very commercially successful. And what we learned there was that when you get the model, when you get an LLM to generate the synthetic data for training, it really helps if you prompt that LLM from like a variety of different perspectives. So it's like, you don't want to, the first prompt we started with was like, pretend you're a professor setting a quiz. And so you give it a bunch of text, and then you can, it will just generate a bunch of questions and answers about the text. But if you also ask it like, to extract metadata about the document, like the author, the date of the document, and also ask it a bunch of different questions from different perspectives, like what, when, why, about different like sections of the document, then you end up with better training data for these fine-tuned models. Another couple of things we learned was that API calling is quite different. It's subtly different to the function calling that we learned about earlier, because it's kind of doing more than function calling, because it's not just allowing you, the developer, to plug in functions that you provide to the model, but it's actually building a system which can make the API calls on behalf of the user and which understands open API specs. And the other thing about our API calling implementation is that we did it without function calling, because the open source models we were using to begin with didn't work with function calling. So we've implemented API calling entirely with prompting. And that's now working in production for customers. Another fun thing we learned was that if you run like 50 Ollama instances across a Kubernetes cluster, like one Ollama instance per GPU, and then you upgrade all of those containers at the same time, then you will absolutely destroy the network of that Kubernetes cluster, because every Ollama instance will start like 50 concurrent HTTP connections to download the weights at the same time. And like we had this wonderful company called Helix.ml donate us a bunch of GPUs on a Kubernetes cluster to use. But every time we upgraded our product, it would just break their network, and I get a Slack message from Pavel saying, like, I'm trying to work on this internet connection, can you please stop? So what we learned was that the best way to do this is actually to bake the weights into a Docker image. But the fun thing about baking like 100 gigabytes of weights into a Docker image is that Docker images by default use gzip compression, and gzip is very, very slow. And so you end up just spending like an hour trying to compress 100 gigabytes. And the fix for this is to make a one-line patch to the Docker source code. There's hundreds of threads on GitHub about this problem, and I found the one like comment in all of those threads, which was like, if you just patch the Docker source code to set the gzip compression level to 0, then you can build images that can be read everywhere, and which are basically free to compress and decompress. And the weights are highly compressed anyway, so there's no point gzipping them. So we run this like patched Docker binary on our CI system, and it generates these wonderful Docker images that decompress really quickly. So that was a fun kind of lesson learned. GPT script on the server is another interesting one, because GPT script is brilliant, but it's really designed to run like on your desktop environment. We got that working on the server first in a micro VM, but then also in a container environment where we spin up like a number of workers, and they will run GPT scripts over and over again, and so on. Very quickly on RAG, the first implementation of RAG we did was Llama Index with pgvector with unstructured, and the problem with that was it was a 12 gig Docker image, and we want people to be able to download our software and use it easily, so we ended up switching that out just a few days ago for TypeSense plus Tika, which brought the Docker image size down to like 150 megs. I'm being told I'm running out of time, so I'm very sorry. So I just want to very quickly shout out to this AI spec is the format that we're working on for the version controlled YAML. Check that out on aispec.org. And then the last thing is that we have this app challenge that we're going to run for the rest of the evening. So if you're interested in hanging around and doing a bit of a mini hackathon, playing around with the stuff I've just talked about, then please feel free to stay around for a bit. And the challenge is basically like install our stuff and give us feedback on it. And we've got some lovely t-shirts for people who do that. And that's it. Please feel free to connect with me. I'd love to talk to people more, and let's continue the conversation on the MLOps Slack. Thank you.